Okay, the fact that this question is worth 7 marks probably should scare you a little bit. I'm slightly worried now because I haven't thought about how to solve it, but hey, we're going to go boldly into this and I'm sure we'll figure it out. Now, 1 plus cos x, that's all pretty straightforward. Whenever you see cos 2x, that should immediately get your brain thinking there are 3 forms of cos 2x. Which one do I want to go for? Cos 2x can either be written as 2 cos squared x minus 1, or 1 minus 2 sine squared x, or cos squared x minus sine squared x. Where do these come from? I'll go through that in a second. Are they in the formula book? No. So you need to be able to access these from your brain immediately. Cos squared minus x minus sine squared x, well, that comes from the fact that cos 2x is the same as cos of x plus x, and that is in your formula book. Cos of x plus x gives you cos minus sine sine, so cos x minus sine x, which is simplified as that. This then gives birth to the other two, because cos squared is the same as 1 minus sine squared. If I write 1 minus sine squared x minus another sine squared x, that's how I get this one. If I write sine squared x as 1 minus cos squared x, I get cos squared x minus 1 minus cos squared x, which simplifies to this. So these are your 3 options, and you need to choose which one is most relevant. For most practical purposes in equation questions, this one is not very useful. It's where it all started, but in practice, you're going to use the form of cos 2x, which is written solely in terms of cos squared x, or effectively cos x, or solely in terms of sine x. Now, the one you choose is either, sometimes you're going to be a bit of 1 killing. You've got a minus 1 here and a plus 1 here, and there might be some 1 killing, but you need to look at which whether cos x or sine x comes up in the rest of the equation. And clearly here, this one has 1 plus cos x over on the right hand side, so your brain should be pushing you towards the cos version. That's the cos version, that's the sine version, and that's the original. But yeah, this one is going to be the cos version. So we are going to replace cos 2x with 2 cos squared x minus 1. So this becomes 2 lots of 2 cos squared x minus 1 equals 1 plus cos x. Where are we going with this? Expand it, you'll see 4 cos squared x minus 2 equals 1 plus cos x. Let's bring everything over to the same side and make it equal to 0. We get 4 cos squared x minus cos x minus 3 equals 0. Now, you will note that we've got 4 times something squared minus something minus 3 equals it. Does it look like a quadratic to you? It should do. If we replace cos x with y, we get 4y squared minus y minus 3 equals 0. Now, this looks like it will factorize, but it might not. We can use the quadratic formula, or we can attempt to factorize. And there we go, it does factorize. So y is either minus 3/4 or 1, which means that cos x is minus 3/4 or 1. So far so good. This is looking pretty straightforward, you say. So we just do x is the inverse cos of 3/4 and the inverse cos of 1. Now be careful. Whenever we do inverse cos, there are an infinite set of solutions, blah, 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 blah. So do not write that x equals 138 or 0. That's like the worst thing you could possibly say. I know it's 138 point something, but anyway. Because there's an infinite set of solutions associated with these. So let's start with the 138 one. You get your 138, and you can add 360 or subtract 360, but as it happens, we're only interested in the ones in the range of 0 to 360, so adding and subtracting 360 is no good. We just need to use that formula that we mentioned before, where cos of 360 minus x is equal to cos x. So we take that away from 360, and we get 2. And those are our 2 values for the inverse cos of minus 3/4 that fit our range. Incidentally, for sine, it's 180 minus x equals sine x, and for tan, you just keep adding 180s. Or it can equal 0, and if we do 360 minus 0, we still get 0, but if we add 360, we get and so those are our 4 solutions. In fact, we don't need to write or, really, we can just put commas between them, but those are our 4 solutions in that range.